Welcome to the TAPA Asia Pacific and co-host G4S Telematics webinar, Pitfalls, Hints and Tips for the Intermodal Sea Container Transportation. In this webinar, we will learn about the intermodal sea container security risks, as well as available solutions used for mitigation measures. During this session, get to understand how to analyze the operation requirements that will reveal the most common challenges companies face daily and how this can be mitigated with the right tracking hardware and software tools. Our panelist for this evening, Mr. Laimos Panagotis. He is the Vice Chairman and Executive Member for G4S Telematics. Mr. Michalis Chronopoulos, Head of Security Risk Management for G4S Telematics. Our host for this evening is Mr. Kevin Liang, TAPA APAC Board Member. I shall now hand over to our host, Mr. Kevin Liang.
Hello, dear all. Thank you for your timing to attend this webinar. I'm happy to be one of you to attend this ocean container webinar organized by TAPA. TAPA is always sharing latest news and new technology to every member like today. As a buyer, I'm working for HP. So as a buyer, every day for me, I think we all have hundreds of thousands of containers on the way to different destinations. But from the security perspective, how can we monitor those containers while today's high technology and high-speed network? I think this is a new topic to us. I believe today's webinar will be very helpful and useful to you. And from TAPA, we also want to hear the voice from our members. If you have any needs, please feel free to contact us at any time. So now let's welcome to G4S team, Penna and Michalis. And during this webinar, we have 3 poll questions to you. So please help us to answer the questions. Thank you. So Penna and Michalis, now I hand over to you.
Thank you very much. Good afternoon to all of you. We are very happy that TAPA invited us to make this presentation, this webinar. And we think that this is a very hot topic, especially during nowadays. The reason for this webinar is that lately we have received several requests from our customers to monitor sea containers through portable tracking devices. And we wanted to share with you our experience, as well as to give you some practical hints related to the effective application of such solution. Before we proceed to the main topic, please allow me to introduce to you G4S Telematics, which is actually the telematics company of G4S Europe that is part of Allied Universal. We offer monitoring services that protect the drivers and the cargo and improve supply chain security. And we do this for more than 20 years, serving the most demanding brands internationally. Our portfolio solution focuses in 3 main pillars: logistics, automotive, and protection, of course, of people. The basis of our solution follows a risk assessment approach. There is no one-size-fits-all solution in your problems, and you know this much better than we do. And we always start with risk advisory services, where first we have to identify and measure the risk. Following this very important step, we proceed to the solution of the design, to the design of the solution, keeping in mind that whatever solution we offer, we have to monitor the execution and the deployment of this solution, supported, of course, by systems and technology, as Kevin mentioned a little ago. G4S Telematics G4S is a global company with presence in more than 95 countries. In Europe, G4S has established a network of alarm monitoring and response centers utilizing both G4S as well as third-party partners in each country. This way, we offer local services like police or ambulance liaison and guarding in case of incidents by having one centralized monitoring and incident management infrastructure. All local entities use our pan-European monitoring platform that supports integration with installed tracking systems on the trucks and the vans. Please keep in mind that all the information that are included in this presentation is based on real data collected during field tests and sometimes, unfortunately, during actual transports. They have been properly modified to avoid any correlation with actual operations without affecting the content of it. The topics that shall be covered today are presented in the screen. We are going to discuss a little bit about intermodal sea container transportation that, of course, has several legs: the road transportation, the ports and customs, the sea transportation, how we can do real-time monitoring. We shall present some conclusion recommendation from our experience, and then Michalis will take over to present you a real and actual case study, the challenges and the pilot and highlights of it. Let's start with road transportation in the Let's start with road transportation. That is the beginning of the intermodal sea container transportation. As you all probably are aware, TAPA TSR 2020 introduced 3 levels of sea container and road transport security requirements. The highlights of this requirement are that tracking of the container is required, use of locks at the doors, immobilization of the vehicle, container door monitoring, ISO certified seals, and specific response protocols. And if these are difficult or complex to deploy on a truck and a trailer, you can definitely imagine that it is much more difficult to deploy on a sea container that doesn't have the 2 basic components of security monitoring. The first one, we do not have power. The second one is we do not have GSM coverage to the extent that we want. What are the road transportation risks that we have identified during our risk analysis? The theft of the truck or the trailer or the container, the theft of the cargo, partial theft of cargo, smuggling of drugs, weapons in the container, smuggling of migrants in container, compromised cargo, especially in case of sensitive cargo like pharma, driver emergency, and vehicle accident or breakdown. So these are the risks that have been identified and have been assessed. What are the lessons that we have learned during this journey? We have an issue with location accuracy when we are talking about portable tracking devices, because a couple of months ago, we analyzed this in another webinar. Portable tracking devices, especially those that are put in the container, do not have sufficient GPS coverage, and sometimes reporting using the GSM network is not that accurate. With this, we are very difficult to prepare and put some geofencing radius, and of course we have to validate the operational data that we input. There are some solutions in our problem. One of those is the satellite communication. It's a very good solution, but it's quite expensive. So during sea leg of sea container transportation, where most of the times we do not have GSM coverage, how are we going to get information about their location and the status of our container? So if we have satellite communication, this might solve this problem, but it is not something that can be deployed in a big scale. Another solution that is good but complex would be the one where the tracking device in the container gets connected to the vessel's position system, the AIS, and all data from the device are transferred to the monitoring center via the AIS regular daily transmissions. Unfortunately, this solution is extremely complicated and needs to be micro-adjusted every time a container is loaded on a ship. So it's good, but not practical. And we ended up that we are going to use portable tracking devices similar to those that we use in road transportation or in other cases where we need to have tracking of an asset that does not have power itself. So having reached this conclusion, we started evaluating the two major questions. What do we actually expect from a portable tracking or sensing device? The solution is easy. The answer is easy. We expect accuracy to provide accurate measurements and data, and we expect also battery capacity to cover the whole duration of the operation. So two very simple topics that are, if they are dealt with in a simplistic way, it will create a lot of problems. During the presentation, you see also some of the polls that we have designed together with TAPA APAC, and we would be very happy to get your answer and analyze the results at the end of the presentation. So getting back to the presentation, having defined that we are going to use portable tracking device and the two major issues that we need is accuracy and battery capacity, then we started working on how we can develop a solution. Now, the most important thing is that when we work to prepare a solution, we always need to think like criminals, because criminals will not follow rules and criminals will try to find the weakness of your system in order to attack to your system. So I'm sure that some of you already use this kind of solutions. So what we would suggest for you to evaluate your solution are two very, very simple steps. So we have developed a very simple step, a very simple process to evaluate the accuracy and a very simple process to evaluate the battery capacity. Related to the accuracy, before you rely on a portable tracking device for loss recovery, please do the following two tests. Take two of those identical devices and put them on the same pilot route and start evaluating their reports. These reports should be identical because the devices are identical, the devices are put next to each other, and the devices execute the same route. So if you see difference between these two devices, this is something that you should take into account very, very well. Next to that, compare these devices, the reports of these devices, with the fixed GPS tracking device located in the truck, or later you will see with the GPS locations reported by the EIS for the vessel. Again, they should be close. Again, if you see major difference, this means that your devices, the devices you have selected, are not consistent. And consistency is very important when designing response protocols. Because if you have two devices, some of you, some of us, put two devices in a container in order to increase the reliability of the solution. And in case of incident, we get two different locations from each device. And then where do we have to respond? So this is a topic that you should take into account very, very carefully. The next one is test the device, the device battery capacity to accommodate your requirements. So if you want, let's say, to have 15 minutes interval reporting when your container is on the sea, on the road, and 1 day reporting, let's say, when your container is traveling in the sea leg, then define these requirements. And then test these devices whether they can accommodate these requirements. Because you don't have to adapt your requirements to the characteristics and the capabilities of the device. I think that the approach to select a device that meets your requirements is better. Now let's go to the ports and customs. I will present here to you some cases that are real. In 14th of January, 26 migrants were found inside two containers at the port of Salerno in Italy, which have been shipped from Turkey. So I'm sure that most of you have faced these kind of problems. On 16th of January, 9 migrants were detained at the UK Teesport Maritime Transportation Facility after being found in a shipping container newly arrived from Zeebrugge in Belgium. So what we want to show you here is that it is not impossible for somebody to enter into a container. The next slide, the next video that we have here is a video that most of you have attended, have seen in the TAPA trainings. I will not show the complete video. I will only share some parts of the video that show how somebody can enter into a container, and Michalis will share with you in the chat the links in YouTube that you can find this video.
This is the hasp here. The hasp attaches the seal to the handle. The hasp is attached by a TIR rivet. The TIR rivet can be cut. Once it is cut, the hasp is swung around with the seal still intact, the handle is lifted, and the door is open. Once the door is open, the remainder of the TIR rivet is removed, a nut is glued in place, the door is closed, the hasp is swung back around, and a threaded TIR rivet is used to try to disguise any evidence of tampering. Moving down the handle here, this rivet here is what actually attaches the handle to the hub, which is welded to the locking bar. Again, this is a rivet. The handle rivet can be cut. Once it is cut, the rivet is removed, the handle drops down, and a bar can be used as a makeshift handle inserted in the hub to open the container door. Then the door is closed, the handle is replaced, and either a threaded rivet or another rivet can be used to secure the handle. Next, we're going to move right down here to your cam and your keeper. This is your cam, this is your keeper. On the keeper, we want to check to make sure this portion here is not cut off, because if this is cut off, this is what retains the cam. The door can be pushed forward and opened even though the seals are intact. On the cam itself, we want to look at both claws, make sure that they're intact. These claws are cut. Again, the door could be pushed forward even though the seals are intact. Next, we want to look at how the keeper is fastened to the header. We want to check where the keeper attaches the container, because if it's cut away from the container, the door can be pushed forward and opened, and it would be welded back in place to disguise any evidence of tampering. Next, we're going to move right up the locking bar over here, and we come across the retaining bracket. And this is attached by two bolts, has the vulnerability of being able to be cut right across. Next, we come across the retaining flap. The purpose of the retaining flap is to keep the left door from being open, which is not normally sealed, until your right door is open. With a tool, you can bend this flap back. Open the left door and gain access to the container. And Officer Maloney is going to demonstrate that tool. Mo?
It's a simple tool. We take an automobile spring, cut a portion of that away, and we weld it to this steel rod. And what we do is we have a 1/2-inch gap within the two pieces of spring as they're welded. And we take this, place it within the flap, apply some pressure, giving us access to open the door. Let me demonstrate this for you. Slide it inside the clip, apply pressure back, just enough to have the door open.
As you can see, it's not very difficult to open a container without affecting, maybe most importantly, the seal, because currently we use the seal as an indication of compromise or of intrusion. So we presented, and TAPA has found these very useful videos where the seal should not be affected if somebody wants to enter in a container. And then we go to the sea transportation. What are the challenges? Long distance, up to many weeks. This has a very major input on the battery capacity of the device. No communication network. This has a very major input on the monitoring activities that you do. Again, no cargo visibility. And at the end of the day, no response capabilities. So in case something happened and you somehow get the signal, you will not be able to respond. But these are the challenges that we have worked with our customers, and we found some practical solutions that might, and we are going to present later to you in the pilot, that might be helpful for you to consider. A very important part of sea container transportation is the real-time monitoring, because I don't say it's useless to know after the incident that something had happened, but it's not very practical, and at the end of the day, you don't do anything, and you use all this information for forensic purposes in order to analyze them and define and design some preventive measures. But preventive measures are the third step in our approach. When we have an incident, we need to apply a correction in order to stop the consequences of the incident. We need to design a corrective action in order to solve the problem that created our incident, and then we need to decide to define and design a preventive action. So if we use all this data for forensic purposes, mostly we work on the prevention rather than on the correction. I will give you some conclusions and recommendations before we proceed to the pilot case study. What I would like to say is that there is no one-size-fits-all solution for the effective tracking and monitoring in the intermodal sea container transportation, and I'm sure that you all know about this. Each lane has to be assessed separately, and available components should be integrated carefully to form an acceptable solution for this specific lane. Typical GPS and GSM autonomous container tracking solutions can be an integral part of the solution, but alone, we do not consider it is enough. Combination of sea traffic and container tracking data should be presented at the end user in a single integrated form. Road transportation presents significantly higher level of security loss and risks, whereas sea leg needs to be monitored mainly for operational purposes, and real-time exception monitoring provides a significant added value to the effectiveness of the solution, providing an early warning. We have published 2 white papers related to route risk assessment and compliance and loss prevention in pharma transportation that deal with this kind of portable tracking devices as based solutions. For those of you that are interested, please send us an email or send to TAPA APEC an email, and we shall forward these white papers to you. Michalis shall take over now to present to you the findings of one of our case studies that addresses the methodology of dealing with this kind of operations.
Thank you, Pana. Hello, everyone. I'm Michalis Chronopoulos, and I'm the head of security risk management in G4S Telematics. Again, thank you for taking the time to participate in this TAPA webinar. So let's go to our case study now. And what we would like to discuss here is how we approach every case, as Pana said, through our risk-based methodology. So basic questions that we need to answer is what you need to protect, what you need to protect it from, and how is the most effectively way to protect it. And in many cases, you already have put these questions and looking for the answers. So what we're trying to do is applying the integrated security model that we have in G4S and combining all the modules that we have in order to address these questions and the risks behind these questions. So today, what we would like to discuss is about a very specific project that we have done related to transportation of tobacco, which is considered one of the most high valuable goods, and the challenges we faced during this pilot. So of course, we had multiple stakeholders. We had the tobacco manufacturer. We had all the companies involved, 3PLs, forwarders, that they're doing all the transportation work. And again, we had to coordinate all these efforts through a single point of contact for the security reasons, which was the G4S control tower, and all the law enforcement agencies across all countries that this route has taken. So many stakeholders, we needed to define a communication matrix, we needed to define the correct response protocols in order to be effective in this case. As we told you before, the cargo was extremely valuable and there was a great impact on a loss. And operations was challenging also because we had not only to cross many countries with different legislations, different languages, but we had also the intermodal transportation switching from road to sea transportation. And we did not have the ability to have the very expensive and high-tech technology applied in the truck and trailer as we usually do on the road transportation for high security risk transportation routes. So what we had to do is we had to equip a container that is not going to be reused for the same route. So we had to define a solution that was flexible enough to provide what we wanted, but to install it in a different container the next time we need it. Okay, so what we have done is we have identified the risk, we have identified what is required, and then we collected the right modules in order to address this risk. And this is what is integrated security all about. So we have a pool of either people with expertise in order to address these needs, to define them, to do the right training. We have the systems in place and the technology in order to provide the full solution for this pilot. I don't want to take in much time on that. I would like to focus on the case study. So what we have decided together with the customer, because this is how we approach these cases, we work with the customer and we co-create what we define the solution. So the solution for us was to use a portable device in the container and to have a portable device that has all the necessary sensors and data providing what we wanted during this pilot. We wanted to monitor specific events that we have considered to give us the right response time in case we have any specific incident. And of course, we had to have the software integration so the monitoring center of G4S Tower will receive everything and react immediately. As for the operations, we defined that we would like to have monitoring in both legs, road and sea transportation, and all communication would be handled by a single point of contact, which would be G4S Tower. Okay, so what we have done, we have defined the risks, we have defined the technology to be used, and then it's about having pilot runs. And why we need the pilot runs. We need to evaluate the system and the technology. We want to make sure that what we have decided to use is effective. Then we needed to finalize the communication matrix. So all people involved know exactly what to do, when to do it, when to activate the service, and what is expected from the service. And through this process, we had to train our people, and of course, at the end of the day, to confirm that the risk assessment is valid. So the case that we would like to present today is about transportation from center of Europe through the port of Rotterdam, and the final destination would be Dubai. And what we have done in these pilot runs, we have used two different types of devices just for us to validate our risk assessment. One device was put inside the container on the door and had specific sensors like light, temperature, humidity. And one device was put outside of the container as a seal and a lock, and of course, providing also tracking and the necessary data to be used for analysis. Okay, so what was the configuration? The tricky part here is that the configuration was different while on the road leg and different while on the sea leg. And of course, you can understand why. So on the road leg, we would like to simulate what we're doing in a typical road transportation high value route. So we would like 5 minutes reporting rate. We would like to monitor route deviations. We would like to monitor jamming and no communication. And of course, we would like to monitor when the container door was opened or not. And in any case, we needed to have the right response protocols in order to do the intervention when needed. So for monitoring the door, of course, you can understand, in this case, we could not have magnetic contacts in place. So we did it through the light sensor for the internal device, which would trigger a door open event, and seal open if the cable was opened or cut in the external device. Now, for the sea leg part, of course, there's no need to have 5 minutes in intervals. So we had 1 hour reporting rate. And of course, we needed also to monitoring, as we discussed before, about unauthorized door opening while it was on the vessel, and provide an early warning in case this happened, so the customer could respond. So, yeah, okay. So the highlights, what we have seen during this pilot. The happy thing is that it was a successful pilot. So we have collected all the data, we have analyzed all the data, and as you can see here, we have applied what the customer requested. So we had the 5 minutes interval in the road part, we had the sleeve geofence that will give us an indication that the vehicle has switched and took a different path. So we have some route deviations, and we have all the monitoring required during the road transportation. We have multiple sensors in the devices that could provide us the data to work with. And this is how we address the need of having all this data without a fixed device installed permanently on the truck and trailer. So we had light sensors, we had humidity and temperature, which could also trigger a security event if someone would cut off the side of a container. And of course, we had tilt that will give us a few indications about the status of the container. Now, as Pana said before, and this is very important to us, during the sea leg, we have no visibility. Why? Because there is no communication. So in this case, the solution selected utilizes the marine traffic data in order to provide real-time tracking of the vessel, since we cannot have real-time traffic of the device itself. But it gives us a visibility where the vessel is. Now, as you can see on the screen, there were specific areas where the device actually could have GSM connectivity. And in this case, we could get the log of all the messages collected from the device. And if there was any differences in the doors or anything that we would like to respond on, we would get an early message through that connection that during the sea leg, the door was opened. So we can inform the customer, and of course, he has a few days ahead in order to decide how he would like to react in this case. that the cargo was compromised. So through this technology, we have achieved to mitigate the risks, we have achieved to provide the monitoring required to the customer, and we had reliable data in order to make sure that the service would be available at all times. So that's the case I wanted to present. Thank you very much for your time. Now, back to Pana in order to see the results of the 3 polls that you have answered. And thank you very much for taking part on that polls. It will give us a visibility of what you're doing today and how you would like to address any cases that you have through your experience. So thank you very much.
Before we pass the floor to Kevin to moderate the Q&A session, I would like to point out that this is a similar case with rail transportation with some minor differences. In the rail transportation, the GSM network usually is more available than in the sea transportation, but the response activities are not very easy in case, especially when the train is not in an area where that is accessible by car. So I would like to thank you again for your participation. We would be more than happy to answer your questions in the next session. Thank you very much.
Hey, thank you all. So I think before we go to Q&A, so Madhu, can you help me to share the poll results? So then I think we can have a quick view for the results from all the attendees. So I think this is a good result for us to share and to discuss in the call. So from the first one is, do you use the portable tracking devices in your sea containers in intermodal, transportation activities? So I see I think about over 50% we don't use right now. Okay, I think, but the poll is maybe before the call. So I think some of you do not have time to poll this. So, but from this result, we know about 50%, over 50%, we don't have these devices. So I think from this call, I will suggest maybe you can take a look for these devices or these new technologies. So this may help you to tracing and tracking your containers, especially on the sea, because on the sea, we don't have any view for our containers. Okay, for 2 and 3 is a high percentage for yes. So do you consider monitoring in real time the sea containers? And then the last one is, do you think that early warning of containers I think from the security perspective, both are very important to us. The first one is real-time monitoring. If you are familiar with TAPA standards, one is FSI and TSR. So I think both is a very useful tools as a benchmark to check whether your vendors or suppliers is qualifying one. So I think this is a 2 requirements. I think these are very 2 basic requirements in our TSR standards. So real-time monitoring is 1 minute or 2 minutes. We get just like a GPS, we get recorded feedback from the system. And also we wanted from the security, we also wanted to have the early warning from the containers if someone opening the containers. So both are very useful for everyone. I think for every buyer to get this information at when is real time and when is gets the early warnings from the system and the new technologies. So I think this is a very good view. We can see that from all the attendees, these are very 2 important signs for us. So I think let's move to the Q&A. I see there is a questions from the attendees is, do we get a copy? Yes. So if you have any needs from TAPA, please drop mail to us and then we will provide the slides to you. So if anyone needs this, And any other questions from the attendees? Okay, so if no questions from the attendees, so I think I am very pleased to introduce to our TAPA chairman, Lina, to you all, because she is also in the call in this webinar. So Lina, you have anything you want to share too with the, okay, thank you.
Thank you, Kevin. And then also thank you to partner and Michaelis, and also to our secretary team, together with all these members. Thank you for your participation today. I think that is the first time when I read these slides and I discussed with Panna and his team. I really like this kind of sharing, because these are the real experience from the monitoring party to share with us the best practice and also the true challenges faced during the ocean transportation. So I know that we have many members who are interested in this, let's say the intermodal transportation. This is also why Panna mentioned for railway. And we are looking forward to all the feedback and requests from our members, and believe that with all of the requests from different members, TAPA, APAC, we will also help to liaise with different partners, different let's say service providers, to find out the most pragmatic approach with our members to share with you the best industry practice. So here, this is a platform. And again, I think that we will be happy to share the slides with all of you. And if you have any additional requests, please let us know. Okay, thank you, Kevin, and thank you, partner. And Michaelis.
Kevin,
Okay.
I see a couple of questions popping up. If you
Yes.
don't
Okay,
mind.
great. Let's have a look.
So
Yes.
I would like to answer to Luke that
Yes, please.
Yes,
small
please.
question is, given that GPS coverage is a challenge with regard to connection with the monitoring center, does it make sense to install small GPS devices inside our product? Of course, this is a solution, but as discussed earlier, you can use this only for forensic purposes. So you will know at the end of the route that something had happened or that nothing had happened. But most of our customers wanted from us what actually the poll showed in the third question, that if you have an early warning that something happened during your route, you can organize some actions when the contain at the port of destination. So definitely you can use more GPS devices. You need much more than one or two, but this is also an alternative solution. And another question from Martin, how much for portable tracking devices service? We can give you some indication, but it's similar to the fixed tracking devices. The prices for an ordinary are not that high. You can check from various providers. It's not a big expense. Martin, I hope I answered your questions. If other questions are, please, more than happy to answer. And Luke, I would like to listen to your feedback if you are okay with the answer I provided.
Just a small comment from my side related to Martin's question is that the difference here with the portable devices is that you need to collect the device at the end of the route. So in the fixed devices, you have equipment fixed on trucks and trailers. In this scenario that we have presented, at the end of the day, you have to collect the device and bring it back to the origin in order to reuse it. So it's a bit of a challenge, but not something that it cannot be done.
So can I also add on some comments here, Michaelis? I think that this is also require a collaboration between the buyer and the logistics service providers. We did have this kind of approach So it requires a lot of collaboration, and also we have to take into the depreciation into consideration. So as to which option would be the best fit, normally we will also work together with service provider to see to work on different type of cost benefit analysis. So I believe that for company like G4S Telemax, you will also help us as well, right, to perform such kind of analysis. Okay, thank you. So Luke, any have we answered your question?
Yes, I just responded to Luke that this is a
Right.
very good alternative, the one they use.
Okay, thank you.
Okay, thank you. Any other questions? So if you have any questions on this webinar, please feel free to reach TAPA secretary team. So the mail address, I think you all have. So if you don't have, so maybe we can post this to this, or we can reply to you all for any questions from your side, and we will try to answer your questions from GPS and G4S and the TAPA. Okay, so if no questions, so welcome. I think thank you for today's timing to join today's call, and thank you G4S team Pana and Michalis, and thank you TAPA secretary team to organize this webinar. So thank you all. Let's close this call. Thank you.
Here, we appreciate your time. And in case you have any question, just pop us an email. More than happy to respond.
Thank you.
Thank you.